On This Week in Enterprise Tech, Microsoft wants to protect you from Microsoft, China gets 2 million likes, and Aerohive explains 802.11ac wireless. Twiat on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiat, This Week in Enterprise Tech, episode 61, recorded October 7th, 2013. Aerohive explains 802.11ac. This Week in Enterprise Tech is brought to you by Full Sail University. Full Sail offers both online and campus degree programs centered on real-world experiences in the entertainment, media, and technology industries. For more information, visit fullsail.edu/enterprise. And by GoToMeeting with HD Faces by Citrix, the powerfully simple way to meet and collaborate with coworkers and clients from anywhere. You can share the same screen and see each other face-to-face with HD video conferencing, even present from an iPad. Sign up for your 30-day free trial today. Visit GoToMeeting.com, click on the Try It Free button, and use promo code ENTERPRISE. And by TechServe. TechServe assists U.S. businesses of all sizes with their technology needs, including Apple, Avid, Adobe, and HP solutions. Visit techserve.com/Twiat and receive a complimentary iPad deployment assessment. Welcome to Twiat, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballecer, the digital Jesuit, your guide to all things in the enterprise. But of course, I'm not guiding you by myself. I always have an all-star cast behind me, starting with my good friend and geek in paradise, Mr. Brian Chi, who currently is feeling under the weather. You may notice the droopy dog eyes. You may notice that he's at home, and he's actually walking around in his jammies. Brian, aside from being sick, how you doing?
I'm doing pretty good, and just giving a nice shout-out to our friends from London that brought the creeping crud with them.
That's right. You want to tell the good folks at home where you were when you got the creeping crud confunk?
I was actually in Seattle. I said hi to Oliver and so forth. What was interesting is we were talking all about some really cool things, returning 12R2 and so forth. Unfortunately, I can't really talk about them until 3:30 p.m. Pacific time.
That's okay.
So I guess we're going to have to talk about it next week.
No, I'm pretty sure the show will go until 3:30, so we'll just break in when we
okay, there you go.
Okay. Also joining us is a friend of the show, man who you always love to see, Mr. Oliver Rist. Oliver, it's great to have you back. Now say something really cranky.
Brian really imposed on me when he stayed with me. I don't know how to say that otherwise.
Now I understand you're getting ready for a move, right? I mean you're going to be moving back to the proper coast.
Not till next spring. It's looking like.
Okay.
So the market is not very good in the wintertime. The spring market is the way to do it, and I'm still not done prepping the house. And it's again, I think Brian's fault. He's supposed to fix something every time he comes here, and he didn't this time. He just took my hospitality and left.
Yeah. So if you guys want, we can get you a private chat room. You could sort this out.
I think you should.
Okay. But you know what? Before we do that, let's get straight into the Enterprise Bite. We've got a few bits of news. The first one is that Microsoft, I kind of like this, no longer recommends their own antivirus solution for people who want to protect themselves from viruses. That's right. It's Microsoft Security Essentials, MSE, that they're saying, well, even though it spent several years at the top, it was a really good solution. It was fast. It was integrated into Windows. It was one of these free solutions that just, well, it made sense for Microsoft to finally bake into their own product. They're now saying that since the last 2 years, all the metrics have shown that it's just not up to snuff with its competitors. They've given up. They've said, look, it's a baseline. It's something that you can run, but you really should be running another antivirus on top. And they name a couple. They talk about McAfee. They talk about ESET. They talk about Avast and others. Brian, let me throw this over to you. Why are they doing this? I mean, it sounds to me like they're essentially saying, yeah, we can't protect our own operating system, so we're going to count on the third party. What's going on?
I don't know. That announcement kind of caught me by surprise because antivirus is a black art. It really is. That's the unfortunate fact of life. And while there are certain people that are better at it than others, in a lot of cases, when you're when you're trying to protect, I'm almost thinking a external box is better at it, where you can start dedicating a lot of heavy lifting CPUs.
Right. Oliver, I'm one of these people who I don't run antiviruses, or I didn't run antiviruses on my boxes. I made sure everything was patched. I made sure I was always safe in my own private little piece of the network. But I didn't like the performance I took when I installed something from Norton or McAfee or anybody else. MSE was actually able to protect my system with a limited amount of overhead. Now it sounds like they're saying, we can't do that anymore. And does it sound really plausible to you that someone's going to run MSE and another layer of antivirus, or they're just going to turn off MSE, uninstall it altogether, and do what Microsoft says?
Well, I got to shoot you down. Sorry. So they dropped MSE because of Windows 8.1. And if you look at the, quote, marketing term messaging, everything they have on TechNet or whatever, 8.1 is pitching Windows Defender and the Trustworthy Computing Initiative and the fact that it has biometric support natively, things like that. So obviously the right hand actually did talk to the left hand, and they figured MSE was extraneous, and they dumped it.
I like this. Okay, so Microsoft's strategy now is to say, look, we don't need this security solution, but do you think they really want you to install a third-party antivirus?
Well, I don't know where that came from. Windows 8.1, everything I've seen on TechNet and such, they're pitching that, and they're pitching it to the enterprise as well as the consumer.
Wow. Okay. So, Cheever, let's go with that. So, 8.1 is doing away with MSC just because it's no longer needed. What does that tell us about Microsoft's belief in the security of their new product?
Well, sounds like someone's holding their breath and hoping. Realistically, if a machine is well patched and you've closed down a lot of the holes, it's actually pretty hard to get into. When you start talking to people like Ralph Mudge, the Metasploit guy, it's hard to infect or hard to own a machine if there are no open ports. And the realistic view of the world is most modern operating systems don't even open inbound ports unless you're running some sort of service. So the more ports you open, the more vulnerabilities you can possibly get hit by. So if you have a device like Windows Defender and closing down all these ports, then maybe not so bad anymore.
Well, Chibert, I know you still run a couple of Windows boxes. Let me ask you, do you run antivirus, a third-party antivirus in any of your Windows boxes?
Yeah, it's just so easy to miss something. I admit I like closing down a lot of ports. I don't run any services you don't really need. But if you're in a rush, there's still a good chance you're going to miss something. So I'm always been a believer in defense in depth. So I have a gateway antivirus and an IDS running on my firewalls, but I will also run an antivirus on my machines.
Oliver, what about you? Do you run your Windows boxes without antivirus?
Without? Hell no. I don't know what you're doing. I usually have a third party running. I started with Symantec, and they ticked me off. Now I'm on McAfee, and they're ticking me off, so I'm going to try somebody else. And P.S., the Windows corporate image also has third party. Third party, or it's internal protection. It's off System Center. So you can't get into CorpNet unless that's up to date.
Wow. All right. Well, that's what you got. We're going to have to see when Windows 8.1 actually drops out to the public to see exactly what kind of vectors for attack and infection we have. Let's move on to the second Enterprise Byte, which I find, just fascinating. We've got a story here from CNN and others about China's Great Firewall. So they've got over 2 million public opinion analysts. That's right, people whose job it is to look at the millions and millions of posts being made to websites and social media services each and every day, and to make sure that there's nothing in there that might be anti-government or fomenting discontent. They look for keywords, then for context, then, they look for, within that, levels of criticism, and they get to make a decision on how offensive a particular post is and either delete it or take action against the user. This is something, it's a fascinating peek into the system because people have been wondering for the longest time exactly how that Great Firewall works. I mean, we know about blocking of ports, about deep packet inspection, but when you start getting into context, you would need something like this to be able to actually filter and figure out public opinion. Chibert, what's your take on this 2 million strong, which, by the way, is more people than China has in their military, 2 million strong cyber army?
Well, George Orwell, your crystal ball is really accurate. This is very Orwellian. And, at the very opening of 1984, that's what our protagonist was doing. He was actually editing history to make it comply with the current leadership's view of the world. So basically, that's what China's doing. They're basically saying history doesn't matter. The world doesn't matter. Only our leaders' opinions matter. And that's where they're spending their money.
Oliver, I want to tease something out that's more of a fine point, and that is this story is about those who are dedicated to blocking posts from people who might be dissidents or from stopping criticism of the government. I get that. That's old school. We've seen that quite a bit. That's what moderators do. That's what moderators do in our chat room. But recently, we've seen more and more interest in enterprise in this idea of public opinion analyst or public opinion shaper. And the general idea behind that is if you get enough people saying the same thing in social media, you can actually influence public sentiment. You can actually make people think that there is a crowd source, an upwelling, an astroturf effect, if you will, that we've used here in the United States, that is now made corporate. You see it all the time at these conferences, companies that deal with big data and deal with social media feeds. That's why all the major corporations have turned to Twitter as a really good way to reach out to their customers and give their customers a good customer service experience. What happens when a government starts doing the same thing? Uses 2 million shills to write supporting posts for views that they like, or to remove all the dissenting voices so that it sounds as if, yeah, we're all one unified voice. There's danger here, yes?
You think? Yeah, I would say so. I'm just reading. I was reading on the Great Firewall of China. I mean, all their hackers are bypassing it, right? So if it happened in another country, I'm sure that's a pattern. Whether or not the public can, they're making that available to the public is a question mark. I don't know yet, but I would expect so eventually. But yeah, I would think it's a huge problem, especially in China. I mean, that country is moving to a much freer system. So I think eventually they're going to give up. I don't think that they're going to get that totalitarian state back. I think this is a last ditch attempt, and I'm hoping it fails.
I want to refer back a little bit to recent history. I'm not sure if Oliver Chibert, if you remember this, when Dig was still big, before it committed suicide with their site change, there was a group called the Dig Patriots, and it was essentially a big group of a bit more right-wing, more conservative individuals on the internet who would come in and en masse, they would thumb down stories that portrayed either the left in a positive light or the right in a negative light. They would put comments in there, some nasty, some very logical sounding, that seemed to create consensus. And there was definitely an effect. When you got enough people who were supporting a particular opinion, even if it was a generally unpopular opinion, you started to get the hangers-on, people who weren't part of the original group who would chime in. Imagine that, but at a national scale. Imagine that, but at an international scale, not just a few hundred or a few thousand people, but a few million. Chibert, what do you have the power to influence?
This is sounding awful like the Tea Party.
Oh, wait, okay. Yes, Tea Party, but we can also say that about the left. I don't want anyone writing in saying we're being political here.
My big opinion on this is the psychologists have always said that 80% of the world only follow. 10% will do the right thing, but 10% will do the diametrically opposite thing. So the 10% that will do the right thing will go and try and save someone from a burning building, but the 10% that will do the wrong thing are going to run back into the burning building. And that's the problem. A lot of these left-wing or right-wing groups, they're the 10%. They're not the 80%. These people are going to be diametrically opposite no matter what we think they want to do or whatever. Any topic, there's going to be a diametrically opposite group. And I personally think that the way a lot of people ought to look at things is anyone that's really far to the left or really far to the right, that's noise. Throw that away. Go for what's in the middle. Go, look and see what's happening with that 80%.
All right, let me pull it back a little bit from that because I don't want to go off too far on a tangent. I want to keep it enterprise focused. Oliver, there is another angle here, and that is this can actually be a very useful tool for the enterprise. I saw when I was doing Enterprise Connect over in Orlando, there are companies like IBM that have developed incredibly sophisticated algorithms that can tease sentiment out of social media postings. And they can tell whether or not the reputation of a company is leaning this way or that way, whether a product is liked, whether or not it's disliked. And you can get really good metrics off that information that guide your product marketing decisions and even your product development decisions. In this era, where this sort of astroturfing or public opinion shaping is going to be taking place, can you as an enterprise, as an IT worker, not consider some sort of strategy to control your social media message?
You're a step behind.
Okay. Tell me.
Yeah, so for my in consulting and a certain company I'm not going to mention because it's a little dangerous in this regard, there are several companies that do not only what you're saying, but say Nielsen, for example, I don't know if you knew that, they will install specialized software that automatically drops posts that they don't like, right? They do it based on keyword. On top of that, they will put monitors in there, again, looking for that diametrically opposed segment. People who curse you out, people who write long posts disagreeing with some technology statement, and they're automatically and by hand deleted, right? And then they also have, shall we say, posers, right, who are paid by the company who will go in and post what looks like third party or what looks like customer-based posts to shape conversations. And on top of that, they have big data analysis to see how well that's working, to see where the customers are going, all that stuff. So that whole part about deleting the dissidents, that's already working on the enterprise level. And if you're doing any kind of social media marketing, you better be doing that or you're going to fail.
Wow. Okay. Cheever, so follow up on that. The strong statement basically saying, look, this is now the cost of doing business. You have to be involved in this. You have to be shaping opinion because, let's be honest, opinion may be getting shaped against you. In fact, I think Oliver would say you have to assume that opinion is being shaped against you. So if you're not doing this, you're behind in the game. Are we going to be now in a social media arms race? I mean, do you now need to make sure that your army is bigger than the other army? Your public opinion analysts are better equipped, better trained than the public opinion analyst of the corporation you're competing against. Forget nation states. Let's talk about individual companies just competing with each other for a customer base.
Well, I totally agree with Oliver. It's definitely already happening. I actually happen to be one of the masses, I guess you would call it, at Sears. Anytime you buy something, they're going to ask you to go and do a review. Amazon does the same thing. The interesting thing is I actually posted a pretty negative review on this one particular widget, and it just wouldn't post. I tried like 4 or 5 times and it wouldn't post. And then I toned it down, and then suddenly it would post. So I've got a sneaky hunch that it's already starting to happen and that I was a victim of it. But then again, it was a pretty inflammatory post. And at second thought, I thought, oh, maybe I really ought to tone it down. Yes, I think it's happening. Yes, I think everybody's going to be doing it. I don't like it because it's very Orwellian. I don't like people changing other people's opinions just because they don't agree with it. This is a free country. It means that someone needs to be able to stand up on a street corner and yell at the top of their lungs that which will make your blood boil. Everybody's entitled to opinions, and I'm sorry, this is very Orwellian censorship.
All right. I think we need to move on from this topic because the chat room is starting to turn into a incredibly partisan area, and I think maybe we need to give them a timeout. But I will quote one member of chat room who I can't remember who he quoted, saying, just remember 90% of everything is crap. I think that's actually a good rule. You know,
Plus, if you're
when we come back, we're going to be speaking to Matthew Gast from Aerohive, who's going to explain everything about 802.11ac, the next generation Wi-Fi standard that you ever wanted to know. But before we get there, I want to take time to talk about our first sponsor, and that's Full Sail. You know, thanks to advances in communication and business technology, entrepreneurs have the potential to launch their business ideas to a much wider audience. Full Sail University's online innovation and entrepreneurship master's degree program is an intensive 12-month program that guides students through the process for developing a tech-based product or service in a way that takes advantage of these advances. Courses include topics such as the ideation process, product design and development, and financial strategies, which are taught by industry-experienced instructors. Full Sail University is centered on real-world education, so students graduate with a fully formed business strategy and the tools that they need to pitch their product or service to potential investors. Through Full Sail's Project Launchbox program, students also receive a MacBook Pro preloaded with Apple's complete line of creative software tools, as well as degree-specific sets of pro-level applications. Here's what I'd like you to do. If you are looking at making your endeavor succeed, if you are looking at being the next great startup, if you are looking at having the next big idea turned into a real-world product, why not try Full Sail? Full Sail offers a variety of master's degrees in related fields, including internet marketing, business intelligence, and public relations. To learn more about Full Sail's master degree, program in innovation or entrepreneurship, or any of the related programs, check out fullsail.edu/enterprise. That's fullsail.edu/enterprise, and we thank Full Sail University for their support of This Week in Enterprise Tech. Let's get back to it. We've got a special guest, Mr. Matthew Gast from Aerohive. Matthew, thank you very much for coming back. I believe the last time you were in the studio was for episode 3, so you're one of the original guests.
I value having a single-digit episode number. It is a grand achievement in my career.
It is, especially once we get to the quadruple digits of Dwight. That's going to be just amazing.
Well, I will be there as often as you ask me back.
That might take a while. Now, you work for Aerohive. Do you want to really quickly tell the folks at home what Aerohive is, what they do, what they create?
Aerohive's a networking company making a full line of networking devices to move packets around the world. We are best known for our access points and have recently branched out into making routers and switches, all of which are managed via our cloud-managed system.
Right. We've brought you on specifically to talk about 802.11ac. You wrote a very fascinating tome on this. This is actually everything I needed to know about 802.11ac and nothing that I don't. What I love about this is it gives me all the technical standards behind AC and lets me peek under the hood, per se, to see how it differs from the Wi-Fi standards that came before it. Let's go down the list. First of all, I want to talk about AC data rates, because that's one of the things that people care about the most. Is this going to transfer faster? What's the theoretical maximum data transfer rate for 802.11ac?
Well, talking about data rates in 11ac is always a bit of an interesting conversation, simply because there are so many features that combine in the protocol to come together to give you data rates. If you read the spec, it goes all the way up to 7 gigabits a second. The odds that we're going to get there anytime soon are pretty small. The best way that I've found to break it down is that there are really 4 key features in 802.11ac. So we'll take this 200-page specification, it's probably more than that now, and rather than read the whole thing and go through all of the bits that make you learn calculus to understand it, we'll reduce it to just a single slide. And the 4 features are wider channels. So just as 802.11n increased the channel width from 20 to 40, 802.11ac increases it to 80 and 160. The standard allows up to 8 spatial streams. Turns out that that is actually kind of difficult to build, so the current chips on the drawing board only go up to 4, and that's broadly comparable with what we have out in the market today. Most 11n products are 3 streams.
Let me stop you there really quickly, because that's actually a point that I heard over at Interop, which, you know, people love quoting specs and they love talking about, oh, spatial streams. AC does spatial streams, which, okay, really quickly, please explain what a spatial stream is and why that differs from the way that, say, 802.11 ABGN connected to a client?
So it's actually the same as 802.11n. 802.11n was the first to introduce MIMO. So before that, 802.11abg and even 802.11 without a letter, you had a single antenna on both sides. And so it was called, as a backronym, SISO, single input, single output. You have one transmitter, one receiver, and the data goes between them just once. 802.11n introduced MIMO, multi-input, multi-output. So you would have two antennas on both sides. And this allowed you to transmit over the same channel two independent data streams. And what this does is it allows you to, rather than just have one set of bits, you can have two set of bits. And that allows you to double the speed. 802.11n introduced the idea of going up to 4 spatial streams. However, that was never widely shipped. We did get 3, and that's why you get up to 450 megabits in 802.11n enterprise products that are available today, because each spatial stream is capable of 150 megabits, and you transmit three streams across the channel at the same time.
Right. And we spoke about this previously, which is when we have a standard that says I can support 8 spatial streams, that sounds impressive, but you mentioned that right now our chipsets are only going to support 4. Why is that? Why is it so difficult to have more than 4 spatial streams?
Well, it's partly a matter of difficulty, and it's also a matter of prioritizing what to do. When you have such a complicated specification, it's important to choose which bits of it you do. For example, 802.11n was something like 600 or 700 pages, and there's a lot that's in there. And as an industry, we had to decide what we were going to do and which order we were going to do it in. So just like any other business, we focus on picking the bits of the product that are important and provide the most value, and we do those first. So you wind up with this whole roadmap of features that are going to come out in a particular order. And so the same thing is happening here. Could we build products with more spatial streams? Sure, we could. Is it going to provide the most value for our customers and the people who use this technology? Well, probably not. Okay. It turns out that the key engineering challenge in having multiple spatial streams is that you have to tear apart or tease apart this transmission. So you've got 2 antennas on either side. You have potentially 2 data streams going across the radio link. You have to be able to disambiguate between them. So you've got 2 streams coming into your antenna. You have to pull them apart and say, this belongs to the first stream, this belongs to the second stream, so I can take these apart. To do that with 4 requires more work. To do that with 5 is even more work. If you have viewers who are incredibly technical, you have to wind up adding decoders in here, and you need digital signal processing capable of working with multiple streams at the same point. And it's possible to do. You wind up having a lot of what are called Viterbi decoders. They require a fair amount of electricity to run, and so therefore your access point can double as a hot plate to cook your eggs on in the morning.
Right, right. All right, let's get back to data rates. So we've got wider channels, which means we can transmit more data. We have multiple spatial streams, which there's actually an interesting question going back and forth in the chat room. They were saying, does it support load balancing? Well, not in the traditional sense, but having multiple spatial streams that each can talk to a different client is more efficient than doing time division connections, yes?
So the spatial streams are all done at the same time. So you transmit with either 1, 2, or 3 or 4 spatial streams to an individual device. And it's not that there's load balancing between them, you're using all at the same time. And in order to use multiple spatial streams, you typically need a higher signal to noise ratio. So if the noise floor is here, you want to be able to get a signal that is up high enough and allows you to ride above that noise floor. It's very much like trying to make yourself heard at a party. There's a lot of people talking in the background. You have all this noise. If you want to have a conversation with somebody, they have to be talking loud enough to be intelligible over what's going on in the background.
Right.
So it's not really about load balancing. It's more like way back, and I'm going to show my age a little bit here, although I think both of us have aged pretty well, when you would use 2 ISDN channels and balance between them, or even earlier than that if you had multiple lines connected to asynchronous modems.
We actually still have a couple of ISDN lines in the brick house, so you're not that old. All right, so get back to the data rates. So we're talking about the theoretical maximum. My audience is going to skewer me if I don't actually get a number out of you.
6,933 megabits per second.
That's really, really specific. Tell me how that happens.
So that happens when you use 160 megahertz channels, when you have 8 spatial streams, and when you use the new modulation rate of 256 QAM. And so that's the absolute maximum the spec says you can get. Keep in mind that 802.11n went all the way to 600 megabits per second, and we still have yet to see products that really do that.
Yeah, okay. So let's talk about channels now, because one of the interesting parts about AC is the way that it can bond channels. And by the way, we also know that 802.11 AC only works in 5 gigahertz, right? So you've got many more channels to work with.
Absolutely. And one of the most important developments to go on this year for 802.11 AC was actually not a technology development, it was a regulation. Back in January, the FCC announced it was going to try and make additional spectrum available. And if you go back and read the FCC's action, they specifically cite 802.11 AC as one of the drivers for making all that new spectrum available. I actually have a picture of the available channel map in 5 gigahertz. And so this is taken out of the book that you kindly held up. The 4 rows are individual countries or regulatory domains. And across the top is the channel map for the USA. You see all the gray bits there. That is the reflection for the additional spectrum if the proposed rules go through. So you can see just by looking at it, you don't even have to look at the numbers. You can look at the fraction of gray bits that are there. And the way that this figure works is that the top row, the small blocks are 20 megahertz channels. The next row down is 40 megahertz channels. The third row is 80 megahertz channels. And the last row is 160 megahertz channels. So with that, you see that as you increase the channel width, you do get fewer of them. However, even today, under the current rules, you see that you've got 5 80 megahertz channels. And 5 is a lot better than 3, and we built networks with 3 channels in the 2.4 gig band for quite some time.
Right. Now, we always hear the wireless vendors saying that they need more spectrum, and this is what they need it for, right? Because if we're going to be adding the ability to bond channels with wider channels, using more spectrum, more frequency, I mean, the only way to do that is if there's more frequency, more spectrum made available to them.
Exactly. And one of the most positive things about the FCC's action earlier this year is that they specifically cited not just 802.11, but also unlicensed technology in general. And part of the reason for that is that Wi-Fi exists in what was previously considered to be junk spectrum. So it was spectrum that was not really useful because it had so much other stuff in it, and it was widely viewed as being unusable. With Wi-Fi, we showed that it could be usable, and unlicensed technologies tend to be much more efficient. If you look at how they share data or share the spectrum with other devices, they're much better at that. They're able to work in much more hostile environments with a higher noise floor, and they're able to coexist with each other much better because you can't go to the FCC and say, somebody's in my spectrum, please turn them off. So unlicensed spectrum represents really the wave of the future for communications. There will always be a place for traditional licenses where you're allowed to exclude people from your band. But in terms of making short-range communications work of the sort that we depend on every day, there really isn't a substitute for unlicensed communications, and it's very positive to see that the FCC is recognizing the work that we've done as really an electronics industry to make that work, and recognize that with more spectrum.
Right. I want to throw over to Brian really quickly. Brian, this is one of those things that I think maybe a lot of consumers, people who don't really get into the trade pages, who don't really look at the technologies, they always get upset when they hear about, well, why won't my Wi-Fi work? How come there's interference? Most people don't realize that everything we do in Wi-Fi, which has become just ubiquitous, is entirely unlicensed spectrum, and that the reason why there are so many restrictions on what you can and cannot do with Wi-Fi is because we can very easily start using the licensed frequencies, and that's a no-no. It's almost as if, you know, we took a throwaway band, junk spectrum, as Matthew called it, and we turned it into something that has now become the backbone of so many different services. How does the average person see this?
Well, the average person sees it as black magic. That's the number one problem. And the average person thinks, oh, I'm going to be clever and I'm going to go and try one of these other oddball channels, and more likely than not, what's going to happen is they're going to start stepping on the people around them. A lot of people don't even realize that a lot of cordless phones are in the same band. It's called the uniband. And any ham radio aficionado will tell you that the 2.4 and 5.8 gigahertz bands that are typically used for unlicensed devices is so full of garbage that most ham radio people won't even play in the vicinity because it's got too much junk in it.
Yeah, yeah.
So one of the things I do want to tell to viewers is water absorbs, metal reflects. That row of file cabinets is going to bounce the signal all over the place and it's going to really screw up your Wi-Fi in the long run. That really nice bank of plants is going to absorb your RF signal. So keep in mind that you might be able to do a little bit of remodeling in your office and dramatically improve your Wi-Fi signal.
Right, right. Alder, let me throw over to you. I want to give you that common man question once more. In the chat room, Web 3001, he'd asked the question, does an average person even know what a channel is? I'd ask you, does an average person need to know what a channel is?
No. Right. I mean, look at the home routers right now. You know, the Linksys one, their big selling point is press a button, it connects automatically, and nobody has to think about it, right? So to make the consumer products as broadly penetrating the market, he said in great grammar, these companies are doing away with any kind of technical jargon, right? So I believe the management software underneath, if you really want to dig into it, yes, I believe my Netgear gives me the ability to change channels, but the average person, no clue.
Right, right. Matthew, let's go back over to you because I want you to actually explain to us a few technologies that have trickled down into the public consciousness. That's MIMO, multiple in, multiple out, and beamforming. If you were to go to a Best Buy right now or a Fry's Electronics, you would see boxes that have those buzzwords plastered on them. And this one does beamforming, this one does MIMO. And I think the average person now associates that with good. Okay, MIMO is good, beamforming is good, but they may not have a clue as to how that actually works. Tell me, how does MIMO and beamforming work, and how does it work in 802.11ac?
So MIMO works, we've talked about that a little bit. You do need to have the ability to do multiple streams across your radio channel. And so a key part of that is having multiple antennas on both sides. And really what you're doing is you're looking for distinct paths. So you want to be able to say the signal goes out of one antenna and say one signal goes straight, the other one will bounce off the floor. Now that's a very simplified view of MIMO. It turns out, so that mental model is about having one stream on one pair of antennas and one stream on another pair of antennas. If you wind up doing a sufficient amount of higher math, you can have part of the signal going across both antennas at the same time. But we won't do that because that's way too hard to explain. The best way I heard it put was the reviewer of my previous book on 802.11n said, in space, no one can hear you scream, there are no independent paths, and so therefore MIMO doesn't work because there's nothing to bounce off of. And that's actually one of the really cool things that started off in 802.11n when we introduced MIMO, is that for a long time when we were building Wi-Fi networks, multipath was the enemy. So what happens with multipath is you have a signal and it goes different ways, it comes back together at the receiver, and it can actually interfere with itself and reduce the signal strength.
Right, because if it's bouncing off a back wall, it's going to delay and you get the signal multiple times.
Yeah, exactly. For anybody who worked with really old analog TV, the thing that causes ghosts in analog TV is actually multipath. You would receive the signal, and then because the electron beam goes from side to side, you receive an echo of the signal, and that's why you would see two of everything if you had really bad multipath. With MIMO, we turned that into an advantage, and we said, hey, we've got a first path, we've got a second path, we can transmit twice as much data rather than interfere with ourselves. So MIMO is really, it's the key big idea that gave us 802.11n. If there's one animating idea that 802.11n brought us, it was that MIMO is something that is absolutely usable and doesn't need to have any special calibration. It just works.
And beamforming. Give me your layman's explanation of beamforming.
Well, and it's important to talk about MIMO first because beamforming is another refinement on the technique. When typically when we build access points, we use what's called omnidirectional antenna. It sticks up, it receives from all directions just fine. And it's like a standard light. It's like the light that's behind me. It radiates light in all directions. Beamforming is a way of focusing. So it's a way of saying, I'm going to take the energy, and rather than have it go in all directions, I'm going to send it in one very particular direction. So it's a spotlight as opposed to a floor lamp. And by sending the signal in one direction, you're able to increase the power in that direction. And that helps because Wi-Fi is all about signal to noise. My noise floor is here. If I want to have a good data rate, I have to get the signal up here. There are two ways of doing that. One is to turn it all the way up and make it go up to 11. The other is to focus the energy towards the receiver. And if you can do the focusing, which is beamforming, then you can wind up with better performance without having to turn the power all the way up. And one of the reasons that's important is that typically unlicensed spectrum has strict limits on the amount of power you're allowed to use, and so therefore beamforming is one of the ways around this.
Right, right. Okay, now we get into what I think is just the truly inspirational technology, multi-user versus single-user. Now, we're used to single-user MIMO. You have all these different reflections coming together, allowing us to bond them together and increase the amount of available bandwidth. Or we can actually use all these different streams, all these different beams, all these different input and output reflections to serve out multiple users. How does that work?
So multi-user MIMO depends critically on having beamforming in place. So in the past, let's say you had an 802.11n access point and it had, say, 3 spatial streams. When you would use this, you could use 1, 2, or 3 spatial streams to any receiver you wanted to. So if you were talking to a late model MacBook Air that had 3 spatial streams, you'd get the full speed. You'd get 450 megabits a second. But if you had a mobile device, say like my phone, that has only 1 antenna, my phone is only has 1 receiver. So I can only use 1 spatial stream with this device. And what that meant is my 450 megabit access point is constrained to do just 1 spatial stream. With multi-user MIMO, it allows us to use spatial streams simultaneously. So in the picture you have here, I've got a 4-stream AP. It has, so I'm showing it transmitting 2 streams in blue to the laptop, 1 stream in red to a phone, and 1 stream in green to another phone. And the way that it does this is it uses this focusing capability of beamforming. So we'll take one of our spatial streams and we'll figure out exactly where the phone is, and we'll send 1 set of bits to the phone using that spatial stream. We'll take a second spatial stream and we'll beamform to that receiver, and we'll take 2 other spatial streams, we'll send them to the laptop. And the cool thing about radio waves is all waves add by superposition. You have a wave going like this and a wave going like this. All you have to do is add them together. So if we take these beamformed waves and we put them together, then we'll wind up with a transmission that goes in 3 different directions, but it's 3 separate bits. So therefore, we'll have a bit going to 1 receiver, a second bit going to another receiver, and a third bit going to a third receiver. And this allows us to make the best use of these devices, which may only have a single spatial stream. And with the world going to more battery-powered mobile devices, this is a really cool technology. We hope to see it in 802.11ac next year. So that's when we're expecting to start to see reference designs from the chip vendors, which then we can incorporate into enterprise products.
Right, okay. Last little bit of technical wizardry that I want to explain to me is the difference in MCS. That's the modulation and coding set that takes place in 802.11ac, setting it aside from previous standards. What has changed and why did it have to change?
So modulation and coding set is just a fancy way of referring to a basket of things that we do in order to select a data rate. So it refers to both the modulation type and then an error correction code to recover from errors that arise in transmission. So 802.11 uses something called quadrature amplitude modulation, or QAM. And it's basically a really interesting game of darts. So QAM works by taking a set of bits and encoding them as both a phase shift and an amplitude change. So what you're doing is you have a set of bits, and then that is encoded as a phase shift and an amplitude change, and so therefore you as the sender are choosing to throw a dart at the receiver. And what you're trying to do at the other end is you receive a phase shift and an amplitude combination, and then you can decode that to one of the points in what's called a constellation. So as you increase the number of points you're trying to transmit, then it gets harder and harder. So the simplest version, you just have 2 points. So I either have this phase shift and amplitude change or this one. And you can hit the broadside of a barn with only 2 points. To get faster rates, however, you want to be able to have more points. So I showed you the constellation for what's called 64 QAM, which has up to 64 combinations. Now, we can go even better. We can do something called 256 QAM, and the way that works is that you have 256 points. So you can send more and more data by increasing the number of points in the constellation, but this means that the amount of error that you can tolerate is much lower, because you're playing this game of digital darts. If you're going to hit a point and you have that point, you have the ideal point, then you have to hit it more exactly. So when you have two points, you have much more margin for error than if you have many points, because you're going to have some sort of error radius around the constellation point. You want to be sure to hit it, and there's only so accurate that you can be. And this is really just a reflection of Shannon's law, that Shannon said you can transmit as many bits of data as you want through a channel. You just have to have much larger signal-to-noise ratios to do so. And this is part of the reason why 802.11ac is a 5 gigahertz technology. That noise floor, as Brian alluded to in his comments, the noise floor on 2.4 is very, very high, because we have wireless video, because we have cordless phones, because we have remote controls, because we have all of these things. You wind up with a noise floor that's a few dB higher, and that's processing gain that could be used for higher speed, and that's why we use it in 5 gigahertz, in addition to having, of course, the wider channels.
Right, right. Now, coming back from the break, we're actually going to be talking a little bit about 802.11ad and discuss if maybe 802.11ac is obsolete even before it leaves the gate. Of course, that's a troll feed. But right now, I want to take some time to talk about the second sponsor of the episode, and that's Citrix HD Faces. GoToMeeting. Now, building a strong relationship with your team is key for your business. You need to meet with colleagues, with coworkers, with your clients, with people who are in the know, who will help you make the decisions that are necessary for you to continue your successful business practices. You need to meet in order to brainstorm, and sometimes that means that you have that face-to-face connection where you can see the eye raise or the slight pout in a mouth, the quizzical look on someone's face that says, look, please explain this more. That's the kind of information that you can't get simply over a speakerphone or a disembodied voice. But meeting face-to-face is not always the easiest thing to do. Sometimes you're in a different office. Sometimes you have a different schedule. Sometimes you're in different cities or different countries. And that's why I'm so happy to have Citrix and GoToMeeting with HD Faces as part of the Twiat Riot. You see, I use GoToMeeting with HD Faces because it's the powerfully simple way to meet online from anywhere at any time. Now, a few things about GoToMeeting. With this software, with this service, you can share screens, making it easy for your team to be on the same page, even if they're not in the same room. And if you turn on your webcam, you can instantly turn your conference, your screen sharing session, into an HD video conference. And that gives you that face-to-face interaction. That lets you see what your team is thinking, what they're feeling, and it really does change the tenor of a conversation. Imagine every time you've talked to someone on a phone and you're not quite sure if they get what you're trying to get to them. They're not quite sure if you understand what they're trying to tell you, or if they understand what you're trying to tell them. This is the confusion that GoToMeeting with HD Faces can help you to clear up. Now, if you've watched my show from any time, you know that I like GoToMeeting with HD Faces because it really works from anywhere. It'll work on my laptop, on my desktop, on my phone. I can even present from my iPad. It's really that flexible, that mobile, and that connected. I'm not just a spokesperson for GoToMeeting. I actually use it on a regular basis. My work had me jumping from city to city, talking to different people in different parts of the world each and every single day. And most of the time that meant I had to jump in a plane. That's just no good. What I did was I switched to GoToMeeting with HD Faces, and I could do meetings like what you see up on the screen right now, where I could talk to the people I needed to talk to without ever having to leave the comfort of my studio, of my room, of my office. I switched to GoToMeeting with HD Faces, and I haven't looked back. Not only did it cut my travel time in half, but it allowed me to have more interaction with the people that I need to collaborate with the most. It saved my organization money, it saved me time, and it saved my sanity. I love GoToMeeting. It's easy to use, and with HD Faces, it is just like meeting in person. I love it, and I know you will too. So here's what I'd like you to do. I want you to see if GoToMeeting is the solution for you. I want to see if it can help you and your hectic work schedule. To try GoToMeeting free for 30 days, visit GoToMeeting.com, click the Try It Free button, and use the promo code ENTERPRISE. Remember, use the promo code ENTERPRISE. GoToMeeting, meeting is believing, and we thank Citrix for their support of This Week in Enterprise Tech. Let's get back to it, Matthew. This question has actually been floating around the chat room since the beginning of your segment, and that is, well, what about 802.11ad? They've heard about this emerging standard. Shouldn't we just wait for AD? I mean, isn't that going to be so much better? Isn't that going to save Wi-Fi? Isn't that going to be the next generation of connected computing? Why should I buy products with 802.11ac if it's just going to be superseded?
So 802.11ad is another good example of how unlicensed technologies are showing the way of the future. 802.11ad runs up around 60 gigahertz. So we've gone from 5 all the way on up to 60. It's actually an atmospheric absorption peak for communications with satellites. And it doesn't work so well through the atmosphere. It was originally used to do transmissions between satellites outside the atmosphere. But you can use an 802.11 signal over it. With 802.11ad, you wind up with much shorter range because the higher the frequency, the faster it dies off with distance. So when you go from 5 to 60 gigahertz, it turns out that the power of a signal to move a distance is roughly inverse square. So if we make the frequency about 10 times as big, that does make the range significantly shorter. That does mean that you need an antenna that is optimized for 60 gigahertz. It does mean that it's a shorter range signal. The initial applications of 802.11ad were worked on in a group called the WiGig Alliance, which is now part of the Wi-Fi Alliance. And they are focused on very high bandwidth, short range communication. So things like, how can I get video from point A to point B? And almost like a wire replacement technology. There is the possibility in the future that having something that is shorter range will enable us to offload the technology that is widely used. So just as we use Wi-Fi to offload cellular networks, we might use 802.11ad to provide a short-range capacity boost for 802.11ac. But the real power of 802.11ac and the reason why it's taking off is that it is backwards compatible with everything you have. You put in an 802.11ac access point, it can speak to anything that you already own because it's using the same frequencies.
Right, right. Whereas 802.11ad is an entirely different set, new equipment. It does not read any of the previous frequencies, any of the previous standards.
Right, so you'd need an extra radio. So 802.11ac access points, like all enterprise-grade access points, they'll have two radios. One 5 gigahertz radio for 802.11ac and one 2.4 gigahertz radio that can only do 802.11n. And that's really a reflection of a couple of things. One is, of course, the standard says it's 5 gigahertz only. The second is, as we've been talking about, 802.11 in the 2.4 gig band has really reached its limit. You have enough noise that it's harder to get additional signal power to provide higher data rates. And the band is so crowded that it's relatively small. It's only 83 megahertz wide. So there isn't really that much of a capability to add additional channel width because what you're really saying is, I want the entire 2.4 gigahertz band to be free. And if we can just find a spot like that on Earth, chances are it doesn't have things like water and power.
Right. So we're probably not too concerned about Wi-Fi.
No.
Yeah. Okay. All right. So let's bring this down to brass tacks. You've given the audience a fantastic technical overview of 802.11ac. Hopefully they'll replay it several times and unpack what you've just explained, because you've talked about the technology, you've talked about how it works, you've talked about how it's different from 802.11ad. Now let's get down to brass tacks. This is the part of the show that's going to be for that CTO or CIO who's actually going to say, wait a minute, is this a technology I'm going to deploy in my enterprise or not? And there's a couple of questions that people always ask. Is this finally the wireless standard that's going to replace wires? 2, is this the wireless standard that I'm going to need on every single one of my devices in order to make it work in the next generation network? And 3, is this going to be cost effective in the long run? What would be your responses to those 3 questions?
So this is obviously the direction we're going, that 802.11ac provides additional capacity, and capacity is the name of the game. I've now been in this industry a long enough period of time that I can jokingly describe my career as a series of bets that users want more speed. And it's hard to think of a way that that might have gone wrong other than working on ATM, which thankfully I didn't do. As a result of that, we are getting to the point where we're trying to wring as much capacity as we can out of these frequency bands. And the explosion of devices, that the last time I was on your show, we had some joking about tablets, but now it seems like everybody carries one, and everybody carries a smartphone that they have to get on Wi-Fi. The phone that I held up earlier is one of the first 802.11ac phones that's out there, and it gets a great speed boost by supporting the wider channels. So 802.11ac devices are coming onto your network whether you like it or not. I certainly didn't get any authorization from Aerohive to buy my new phone. I wanted a new phone, so I bought it, and of course I'd like to be able to use it on the corporate network. So 802.11ac devices are coming. How do you accommodate them? And how do you accommodate the massive number of devices that's now coming in? And the way to do that is to choose a network technology that offers higher capacity. And 802.11ac is the game in town to do that. Is it cost effective? Well, fortunately, one of the things about choosing a technology that literally every device that might come in the door supports is that that volume helps drive costs down. So 802.11ac right now is priced at a 20 to 30% premium on the access point side, but I fully expect that as we move over in the next couple of years to shipping more 802.11ac APs than 802.11n APs, the price will come down, and the price of an enterprise-grade access point will come to where it has always been, probably around the $1,000 range.
Okay. First question, and this one is circulating around the chat room. What phone do you have that supports 802.11ac? I didn't realize that it had actually hit mobile devices yet.
The first phone that was announced with 802.11ac was the HTC One. I bought a Samsung Galaxy S4.
Ah, okay, yeah, that'll do it. That'll do it. Now, let's go a little bit off. I want to go to Oliver first. Oliver, so you've heard the technical description of 802.11ac. You've heard Matthew talk about why you're going to want it in your network, why it's a good upgrade path, why it's a good technology for you to choose. But give me more of the executive look at this. Is there enough meat on the bone of 802.11ac to convince someone that this is something they actually need to invest in, replacing their infrastructure and replacing all the clients that they may have in order to take advantage?
Talking about a CFO? You're talking about a CTO?
Well, I mean, we know that the CFO is going to say, let's talk about a CTO.
CTO, yes. Or a CTO, I would pitch my CFO on this in a heartbeat. Well, okay. First, I would measure the throughput and user satisfaction in the office. If I'm talking manufacturing, if I'm talking a tough environment, it's kind of a no-brainer. The CTO who's managing a giant multi-floor office building in New York City, he will definitely test his Wi-Fi and his user opinion about how fast it is. And then he'd make the decision. If they're all ticked off and he's getting phone calls on a Sunday at 2 a.m., yeah, he's going to pitch it.
All right. Cheebert, let me go over to you because you actually exist on a college campus where systems like this could significantly increase the amount of bandwidth available to people on campus, in classrooms, in laboratories. How difficult of a sell would this be to, say, your dean saying, we need to outlay this much money to upgrade the infrastructure of our wireless system, even though maybe we just upgraded 3 years ago?
A lot of it's all about how can you take a limited resource. RF is a very limited resource. And how do you serve more people with the investment that you've made? And since it's a limited resource, doesn't it make sense to be able to steer those beams, to be able to take advantage of areas that normally we couldn't provide great service to? So it gives you the ability to provide better services, more services for less money in the long run. I personally love the idea of AC just because we're going to hopefully start getting rid of a lot of these really crappy systems out there that keep choosing, having bad choices on what channels they're on. They keep, I personally think omnidirectional antennas are something that we need to get rid of because it wastes energy and it throws a lot of trash in the air. The higher frequencies are great because you can do all kinds of really neat things. Anyway, one last comment on the 60 gigahertz thing is, oh, by the way, if you watch the Sony Open, that's how they're getting the HD and 4K video off the 9th hole and back to the broadcast truck. Right. It's also how in Japan, where digging up the street is insanely expensive, 60 gigahertz waves are small enough that it can actually shoot down back alleys. So AD looks like it might have some really interesting point-to-point or what's called bypassed wireless applications.
Right. Matthew, I do want to come back to you with one more technical point because, again, this is floating around the chat room. There are a lot of people who are concerned about AC only being 5 gigahertz, AD being up in 60 gigahertz. We know that the higher you go in that number, the smaller the wavelength, that the less it penetrates. It may be able to carry more data, but it doesn't go through walls quite as well. And so they're saying, wait a minute, can we honestly get rid of 2.4 gigahertz if we're dealing with such high frequencies that are not going to penetrate walls, that are going to require the installation of more and more APs in order to provide the same service? What would be your general response to that?
Well, the transition is driven by much more than what the technology is capable of. It's also by what devices you want to serve. So when we had the transition from 802.11g to 802.11n, that was really the first time that a lot of enterprises started to look at using the 5 gigahertz spectrum. And in order to do that, they had to have enough 5 gigahertz capable devices. And at that point, what many of them found was that buying a dual radio access point it cost a little bit more upfront to buy an access point that had 2 radios. But the real cost in installing a wireless network was to run the cabling and hire somebody to get up on the ceiling and mount the access point. So we're seeing the same thing here with 802.11ac, that if you're looking forward over the next several years at the capacity you'll need, and you look at an environment like Brian's where a quarter of the devices are new every year because you get a new class of students, then trying to find high capacity areas that will benefit from having increased throughput and increased capabilities is almost a no-brainer. That you don't have to say, I'm going to make my entire network everywhere 802.11ac. I'm going to pick out areas where people tend to gather. So it may be that I know that the student union at lunchtime in the lines is going to be, that's going to require very high capacity. So I'm going to put 802.11ac there. I'm not going to put 802.11ac in a hallway on the backside of a building that nobody likes to go into. So right now it's mix and match. And one of the things that the IEEE standards process is very good at is identifying where standards need to be backwards compatible and building things that will work with everything that has come before.
Yeah. Brian, I want to throw this over to you because it's what Matthew was saying strikes me as a very interesting time for engineers because we now have 3 legitimate standards or sets of standards. So everything coming before is one. Now we've got AC and we've got AD, and they've got very different deployment use cases. If we're doing AC, we're talking about really high density, but not a whole lot of penetration. If we're talking about AD, we could be talking about those high bandwidth backhauls, and everything else that came before it is the 2.4 standards, the more penetrating standards, the standards that serve clients that have been in the wild for that much longer. We really do need to start looking at Wi-Fi as what is best for that situation rather than the magic bullet, the one single AP that's going to fix everything, right?
Yeah. This is actually a great time to be a network specialist because there are so many tools available to you. What the network people need to do is they need to stop thinking about, oh, I want to cookie cutter my entire campus or my entire building. That doesn't work, and it can't work. Laws of physics work against you. You need to take a look and tune what devices you use. It's not going to be a one-size-fits-all. It's going to be, I need certain types of tools that fit certain situations. And, like we're saying, an AC makes a really big amount of sense in, say, a large classroom. In the bad old days, a standard AP would tip over at 20 or 30 users, which is the reason why a lot of the new corporate APs have multiple gig pipes to them. So this is actually a great time to be a network specialist because you have the tools. Before, you just crossed your fingers and hoped it worked.
Yeah. Oliver, you've always had a really, really good view of the wider field of technology. And I want to throw this little factoid to you. This was given to us by Scott M32768 in the chat room. He talks about the transition between wireless standards, going from B to G. That took forever. People really didn't adopt G that quickly. G to N was a little bit better, but in all cases, we saw the APs come out first, and then the clients kind of lagged. It was difficult to find a client that could use the new standard, so why would you install the new standard? He senses something different because we've had AC clients out already for quite a while, actually, and we're just now starting to see the APs come out en masse. And it's going to be a different experience. It's going to be people who are using one standard for the longest time on a device, and suddenly an AP gets installed, and boom, they suddenly have a massive increase in available bandwidth. Is that a better way to deploy? Is this going to give people a better customer experience? Is this going to convince people that, yeah, AC is something that I want my enterprise to deploy?
From a CTO perspective, yeah. From a user perspective, it's definitely the right way to do it because they don't care. If there's suddenly one day their throughput gets huge, happy days. If it's a CTO, he's got to deal with cost versus benefit. So that's a different question. I believe if he knows or he knew that under BYOD, bring your own device, he'll see more clients that have AC capability. I'm certain that would affect their decision.
Fantastic. Well,
and
gentlemen,
there's actually an interesting protocol feature here, which is that 802.11ac has this ability to select the bandwidth used by a frame on a per frame basis. So every time I transmit, I can choose, is this a 20 megahertz, a 40 megahertz, or an 80 megahertz frame? And one of the things that this allows you to do is you can carefully lay out how the channels are set up so that it allows your network with AC to give AC speeds to the very first device that comes on. And if that 80 megahertz channel is free, your AC device can use it, can get off the air much quicker. Whereas it is also backwards compatible to the older technologies that you have. And so this allows you to make more efficient use of the airtime by matching the bandwidth of the transmission to the available bandwidth at the moment you decide to transmit a frame, rather than making that decision as you lay out the network for the first time. So even little efficiencies like this make it easier to begin deploying AC incrementally because you get a benefit from the first time you put a client on that supports it.
Yeah, I love it. Gentlemen, what we've been talking about here is all about this new standard and how it's going to be deployed, how it's going to be experienced, which is actually, I think, a good point to stop, to pause, and to talk about the third sponsor of the Twiet Riot. You see, we actually do have a sponsor of Twiet that helps with deployment, that helps with your wireless needs, that helps look at the capabilities of your organization and helps you to upgrade it when it needs to be upgraded. Of course, I'm talking about TechServe. You see, Twiet is all about the enterprise, but sometimes I don't talk enough about Apple products because they are in the enterprise. They will be using these new wireless devices. And so you need someone on your side who understands how they work, who understands how they can best be integrated into your business case. That's TechServe. As New York's premier authorized Apple reseller and technology provider, TechServe serves creative professionals at all levels, from individual customers to Fortune 100 companies. TechServe carries a full range of Apple products, from iPhones and iPads to iMacs, MacBooks, iPods, and accessories. They also have a range of partnerships with top vendors to facilitate flexible, efficient, and creative solutions for all your business needs. TechServe assists businesses of all sizes to deploy Apple, Avid, and Adobe solutions throughout the United States. Whether you're already committed to iPads or just getting started, from sales to support, process to practice, TechServe can help. Now, some amazing technology solutions are already being deployed on iPads. If you've been to the Delta terminals in LaGuardia, Toronto, or Minneapolis, you may have noticed nearly every seat in the terminal is equipped with an iPad. Travelers can now sit anywhere in the terminal and receive real-time flight updates on their iPad, or use them to order food, play games, browse the internet, and check email while they're waiting for their flight. Over 1.5 million users used these iPads in Delta terminals just this past year. The result has been a double-digit increase in food and beverage revenue, and yes, the highest customer satisfaction scores of all participating airports. OTG Management is the hospitality company behind Delta's terminals. They've turned to TechServe to provide, configure, and install the world's largest deployment of iPads, a number that just keeps growing as they add new terminals. And TechServe really was the natural place for them to turn, because they sell, support, personalize, configure, and manage massive iPad projects. It's in their DNA, from the Delta terminals to a school with 700 chef instructors to an operation that delivered personally configured iPads to 3,000 cable technicians. TechServe is able to do a full lifecycle management for all of your technology needs by providing the devices that you need, getting them up and running, teaching you and your staff how to efficiently and effectively use them, and maintaining them so that they're always working. TechServe also provides ongoing support so that if your enterprise has a problem, help is never further than a phone call away. So if you are considering adding iPads to your business, if you're growing, if you plan to succeed, why not ensure your project's success with the world's most experienced partner? Here's what I would like you to do. I want you to try TechServe. I want you to see if they might be the experts you are looking for. If your business is considering integrating iOS technology at your workplace, then contact them today and receive a complimentary iPad deployment assessment. Visit TechServe.com/Twyett, and TechServe will help you assess your current or future iPad needs and give you advice to make it a success. That's TechServe.com/Twyett. And we thank TechServe for their support of This Week in Enterprise Tech. Well, you've done it again. You've used up another hour listening to the best dang podcast this side of the solar system. I want to thank my panelists for coming on, starting with you, Brian. Brian, I know you're feeling under the weather, so double thank you for making the heroic effort to get on headset, on camera, and give us your wisdom. Tell us, what does the Twyett Right need to know about you, what you're doing, where they can find you?
Well, the Twyett Right needs to know that hopefully next week I'm going to be able to talk a lot about some really cool things that are coming out from Microsoft that are going to solve some of the remote access issues that a lot of people have been complaining about. And Microsoft looks like they're going to hit a home run with this new technology.
I like that. It's time for them to have a hit. And Oliver, it's always a pleasure. We keep saying we have to have you on more often, and then we go weeks and weeks, months without having you. So we're definitely going to have you on the schedule more regularly. Tell us, where can the Twyett Right find you? What are you working on other than trying to get Brian to fix your house? Oh, you're muted. Did we lose him entirely?
Yeah, I don't have your audio, Oliver. Put a still.
Yeah, let's put a still in here. Wow, that was an interesting place to have a technical difficulty. It's just as audio?
Yeah, I mean, I'm not getting audio.
This is the quietest I've ever seen Oliver.
Hear me now?
There we go. Okay.
Yep.
So let me give you a lead in again so that it makes it easy to cut it in.
Okay.
Oliver, it's always wonderful to have you on the program. I know that we always say we should have you back more often, but you go months, weeks without seeing you. So tell us, how can the Twyett Right find you? How can the Twyett Right find out what you're doing?
Well, the Twilight Ride is not going to see me for probably 5 to 6 months because I'm working with Brian to get myself to Hawaii for what I believe we're going to try to do 4 big tests in a row so I could stay out there 3 weeks a month for 3 to 4 months, which would be awesome. But we have to plan it out. It should begin with a fantastic private cloud shootout. If we can make that happen, hopefully that will make the Twilight Ride happy.
Well, we could turn it into a game. Everyone should fly over to Hawaii and play Where's Oliver? Now, I'd like to thank my in-studio guest, Matthew. Thank you for coming back on. You know, now I remember why I made you my third guest. The amount of knowledge you have about Wi-Fi standards is just ridiculous. Tell us a little bit about yourself. Tell us about Aerohive. Tell us where we could find your gear, your products, your services, your solutions. Just tell us.
Well, by day, I'm a product manager at Aerohive Networks. You can find all about our complete line of networking solutions, including our recent announcement of our 802.11ac access points at aerohive.com. It matches the lettering in the lower third of the screen. And when I'm not busy driving the 802.11ac transition, I am trying to automate my house. You can follow both adventures at the same time on Twitter at Matthew S. Gast.
Ooh, I like that. Home automation. And of course, you know, we couldn't have this show without the person who pushes all the buttons, who makes sure that all the titles are right and the website looks okay. He's the man, he's the myth, he's the tall guy behind the board, Mr. Jason Howell. Now, Jason, rumor has it that you run a show here at the Twit Network that is almost entirely about Android.
That's exactly it. That's a good alternate name for it. Almost entirely all about Android, except we decided to shorten it and name it just All About Android.
Oh, okay. I get that.
Remove the
Catchy.
ambiguity around it and just, commit. And you can find it at twit.tv/AAA.
Yeah, of course, of course. And of course, I want to thank everyone here at the Brick House, which, by the way, helps us to put this show out every week live. Did you know that we're live? That's right. Right now, Mondays at noon, you can come to live.twit.tv. You can watch us put the show together. That means you get to see how the sausage is made. You get to see all the outtakes. You get to see pre-show and post-show. It's a really good way to join into the Twit community. And by the way, another good thing to do, if you're going to do that, is to jump into our chat room. We have one of the most active chat rooms on the planet, and that's actually not hyperbole, at irc.twit.tv. There you'll be able to talk to the people on the show. You've seen me pull comments straight out of the chat room, and you will find some of the brightest engineers and some of the funniest trolls ever. Also, as a special gift to you, because we love you, we want to make it easy for you to get each and every single episode of Twilight into your device of choice each and every single week automatically. I know, whoa, right? Yeah. If you go to our show page at twit.tv/Twilight, you'll find all the different ways that you can get our feed dropped into your iPad, your iPod, your tablet from Android, your device of choice, basically. Even if it's a zombie Zune, we'll find a way to get our goodness into your hotness so you can listen to it with your earness. Also, I want to thank CyberDog in the chat room, and I want to thank everyone who has stopped by our YouTube channel at youtube.com/Twilight, because there they've been able to watch not just our full episodes, but also the individual segments that we post, the pre-recorded segments, the stuff my IT guy says, pro tip, pro gear. It's, again, one of the ways that we try to give back. I'm Father Robert Ballasare, and I want to remind you, I don't know what's going on in the Enterprise. Just keep Twilight.